So, transposition of formulae. Who knows what I'm talking about? I promise I won't pick on you. Who's heard of that before? Raise your hand. Or a finger. Not that finger. Yeah, good. Okay, cool. So, it's really simple. It's like when you make a variable the subject of the equation. So, I'll show you the example first so you can see where I'm headed here. Like this, which we'll go through in a second. V equals the square root of 1 plus s on t squared. And you're told to make t the subject of the equation. When you see make t the subject of the equation, it means you want t on the left and some sort of expression on the right of the equal sign. And what you've done is you've transposed the equation. Trans means to move, pose, position, moved where it is. So transposition is moving a variable from where it is to the left-hand side effectively. I'll go back to that first page. So when you see make t the subject of the equation, it means put t on the left and everything else on the right. If you see, say, for example, write this equation in terms of x, it would mean x is on the right. So if I said write the area in terms of x, it might be x times 1 plus x. A equals x times 1 plus x. So the x will be on the right. So transposition, we're talking about making a variable the subject of the equation. Okay, so general approach here. So this is something you can write down if you want. Generally speaking, with a lot of these formula rules here, I'll show you the whole four. Is that big enough at the back? Not really? Yes, but no. I'll make it, see if I can make it slightly bigger. No, that's probably that as big as I can make it, to be honest. So feel free to get your laptop out and so it's right in front of you then. If you can't see it, fire up your laptop so you've got it right in front of you. Or come up the front. So the general approach is as follows. If you can, remove the target variable from the denominators. Okay, so if it's in a fraction, get rid of the variable out of the fraction, out of the bottom of the fraction. Number two, rename the target, remove the target variable from one side of the equation. And it's usually on the right-hand side because you want the variable to be on the left eventually. Now, remove is in inverted commas there because we need to remember that when it comes to algebraic manipulation of an equation, the lazy thinking is that I take it from one side and put it on the other. And practically, that's what happens. But the important algebraic principle behind is what you're doing is you're creating a brand new equivalent equation. So when you divide out or subtract a variable on one side, you are dividing or subtracting by that variable on the other side to keep it as an equivalent equation. And that's the important algebraic principle. This is called Maths Methods Foundation for a reason, and foundations are really important. You need to make sure you're really precise with your thinking about something. So you remove the target variable from one side of the equation and then use algebraic techniques to isolate the target variable, e.g. by common factor. And we'll see this come out in the example here. Okay, so let's look at this example here. So as I said, step one is remove target variable from denominator. And the example we've got there is v equals the square root of 1 plus s all over t squared. So we need to remove the target variable from the denominator, but we can't. Why not? Sophie? Yeah, because of the square root sign. When you think about fundamental algebra, I suppose, it doesn't hurt, unless you're really solid with your algebra, it doesn't hurt to start thinking about how an equation is built up, because in order to get to things like the t squared, you need to figure out how that expression is built up in the first place. So you've got 1 plus s, then you've got it divided by t squared, and then the whole thing is square rooted. That's how you would build it up. So if there's a square root that's done before you divide it by t squared, you're going to have to undo the square root in order to get to the t squared on the denominator, if that kind of makes sense. So if you think about how the expression is built up, you're basically working in reverse to get at the variable you're looking for. Okay, so we just apply opposite operations at that point. So what's the opposite operation of square root? Hello. So we do that to both sides. So we square the square root on the left, it disappears. We square the v on the left. Did I say left before? We square the square root on the right, the square root disappears. We square the v on the left, and it becomes v squared. These are equivalent equations. Okay, in other words, it's not the same equation as above, but both equations work for the same values of v, s, and t, whatever they are. Both equations work with the same values for v, s, and t. So they're equivalent equations, and we keep doing this equivalent equation work till we get to the bit we're looking for, which is what is t. So moving on, feel free to work ahead if you want to. I can now look at my step one there, which is remove target variable from denominator, because that's basically, as soon as I can, that's what I want to do. So I'm going to do the opposite of dividing by t squared, which is multiplying by t squared. And so I'm left with v squared t squared is equal to 1 plus s. Is that okay? Yeah? Okay. Remove target variable from one side of the... I've done that as well. The target variable does not exist anymore other than on the left. And now I'm going to use algebraic techniques to isolate the target variable. In other words, now that I've got it in one spot over on the left, I'm now going to do whatever I can to make t by itself. So, for example, well, not example, what would I do next, do you think? Yeah, divide by v squared, because that leaves us with the t squared term. Boom, boom, shake the room. Are we done? We've got t by itself. There's nothing else on the left-hand side. And so are we done? Because we have to square root both sides as well, right? We were asked to make t the subject of the equation, not t squared. T squared is a different value to t. If you don't know that, then I'll give you $3, you give me $9, and we'll call it even. Okay, so square root both sides, and you get t is equal to the square root of 1 plus s on v squared. How's that? Is that all right? I'll be happy with that. If you gave me that as an answer, I'll be pretty happy. There is a slightly better answer. Anyone know what it is? When you square root a whole fraction, it's the same as square rooting the top and square rooting the bottom. So slightly better. Because we've got a v squared on the bottom, we could just leave it. Oh, I'm sorry, that is really squishy. I'll just zoom up for that. We've got square root of 1 plus s over v as a better answer, really. Simpler answer. What do you reckon? Let's try from a more difficult one. These notes will be on Google Classroom along with the video later, so if you're not quite keeping up, that's the other good thing about having it on your own computer if you want to. You can take screenshots of the browser window as you go along if you do want to have them there for you. But I'm going to switch to the next screen now. I've got example 2. Might give you a chance to see if you can get ahead yourself. It's quite scary looking. What makes this different from other problems is that you've got s in multiple locations. We're making s the subject of the equation. And when you do that, you can't just square root both sides and be done. S has to exist all by itself on the left, and then you can have other stuff on the right. So you've got to keep on manipulating that until you've got s by itself. I'll give you a minute or so to try. Yeah, for those who we're just new to this process, guys, so don't stress about it. But for those who are new, even if you're not going to write the summary notes down, it's probably worth having a book open so that if I do give you examples to do, you can just get stuck into it.
That's a 1.
Yeah, it's a 1. Yep, so it's s squared equals a plus s cubed all over 1 plus s. And we want to make s the subject of the equation. I'll actually even zoom that up because I don't have anything else on the screen. That's a 1, not an L. It doesn't matter if you're a non-starter. I'm going to go through it in 30 seconds anyway. Don't expect you to be able to get through it, but just try and follow through that same process that I gave you. If the variable appears as on the denominator, get rid of that denominator. There's nothing getting in the way of the 1 plus s. So how would you get rid of that 1 plus s? Then remove the variable from one of the sides of the equation so that it only appears on the other side, and then do what you can to get s by itself. Honestly, I mean, these steps that I gave you are really loose steps, really. Ultimately, when you get more practice, you'll intuitively take those steps yourself. But don't feel like you have to get it intuitively to start with. Try and follow a process until you feel comfortable enough to just go for it, really. Okay, I'm going to start unpacking this. Don't look up if you don't want to be. This is spoiler alert. The first thing I did is multiply both sides by 1 plus s. But because it's a compound expression, it's an expression made up of the addition or subtraction of stuff, I have to put brackets around it because it's s squared multiplied by the whole of the denominator, not just s squared times 1. Then I'm going to take the s cubed over to the other side. Oh, now I'm doing it. Now I'm going to remove s cubed from the right. And because I'm subtracting it from the right, I'm subtracting it from the left as well. Like so. So now, well, if I wanted to make a the subject of the equation, my job would be done, even though it's on the right. My job's done. That's lovely, isn't it? But unfortunately, it was nasty enough to make it S, not A. Okay, so I need to somehow figure out getting S by itself. Nothing really presents itself. Maybe I could take out a common factor of S squared, but I've got an S inside the bracket that I think might cause me trouble anyway, even if I had a common factor of S squared. So I can't see anything logical here. And again, with intuition, you'll just see it. Because, not with intuition, sorry, with practice, the intuition will kick in and you'll just see things like, oh, if I expand this, I'll get an S cubed and that'll remove this X cubed here. Oh, that's nice to know. So a bit of stepping back and thinking about what the impact of an expansion would be will help you out here. So I'll expand and that gives me S squared plus S cubed minus S cubed is equal to A. Good news, we've got two common terms there, S cubed and minus S cubed, or like terms, so they'll eliminate each other. So it ends up being really simple, even though it looked really hard at the start. So S is equal to the square root of A, and we're done.